All right, so I'm going to go over some practice data with you for the gas stoichiometry lab that we did on Friday. So here is, I might go a little too fast because I have to go home and pack, sorry. So you might have to pause every once in a while if I go too fast. All right, so my partner and I collected some data. We measured the mass of the magnesium ribbon. This was my number, 0.047 grams. That's two significant figures. The volume of the gas was equalized at room pressure, and we found out that we had 48.0 milliliters. The room pressure was read. The barometer read 101.3 kPa for that day. The temperature of the room was 22 degrees, and we did this at the end of the day, and the water had already equalized also to 22.0 degrees Celsius. So you hopefully already have your balanced chemical equation. The first question that we will ask ourselves is, what was the temperature of the gas? If you recall, the temperature of the gas was never directly measured, so we have to kind of guess it. My partner and I agreed that since both the numbers were 22 degrees anyway, and that the gas had had time to equalize back to room temperature, we are going to use 22.0 degrees Celsius as our gas temperature. Gas temperatures have to be in Kelvin, so that would lead to 290, what is that? 5.0 Kelvin. The pressure of the dry gas, if you recall, the gas was collected over water. And so there's also small, not only is there hydrogen up here, but there's also small water molecules. And Dalton's law of partial pressure says that we need to subtract out those water vapor pressure molecules. So the pressure of the room that day was 101.3 kPa. According to the temperature of my water, I am going to subtract out 2.5 to get a dry pressure of 98.7 kPa. So that will be the pressure of our gas. That is the temperature of our gas. The number of moles, in order to do the ideal gas law, we need to have pressure and volume and temperature. We also need number of moles. So to calculate this, it was determined through stoichiometry. There is a ratio between magnesium and hydrogen. It is a 1-to-1 mole ratio. If I am going to start with, according to my data table, 0.047 grams of magnesium, I can then calculate the number of moles of hydrogen theoretically expected to be produced. So always start with what's given to you in the story. In this case, we started with 0.047 grams of magnesium. I am now going to stoichiometrically come up with the moles of hydrogen. So to do that, you need to be a mole. If there's a 1-to-1 mole ratio, I need to molar mass magnesium to convert to moles. At that point, I'm ready to cross my bridge. In this case, it is a 1-to-1 mole ratio. Type that in my calculator. Two significant figures. My answer is moles of hydrogen. So now I'm able to use the ideal gas law to calculate the theoretical volume. So I am solving for volume. Remember, feel free to pause this at any time. I am solving for volume. I need to get rid of pressure. So if I can put my number of moles on top, my R value, which is, I'm going to use the kPa R value. It is a derived unit. It has many units, so this whole thing really is R. The temperature of my gas we determined to be 295, and the pressure of just the dry gas. So if I get my units to cancel, I still believe I'm in liters. We need to be in milliliters, so I'm going to times that by 1,000. For every 1 liter, there's 1,000 milliliters. And I'm going to get my value. According to my calculations, my answer is, what is it? Sorry, I got to type that in real quick. Everything on top is multiplied. Everything divided by everything on bottom. And that is 47.2. So my theoretical value is 47.2 milliliters of hydrogen. So percent error is what I got in my experiment minus what I should have got divided by what I should have got. According to theory, I'm supposed to get 47.2. I'm going to flip it over and find out what I actually got according to my lab. 48.0. And now I can determine my percent error. 48 minus 47.2, enter divided by 47.2 times 100. I got a 1.69% error. That's awesome. So, no conclusion. Feel free to pause and rewind as many times as you need. Turn that into My Big Campus. Don't forget to study for your test and send me lots of messages with questions. Have a good spring break. See you next week. Bye.